OFNR, which stands for optical fiber, non-conductive riser cable, is engineered for vertical applications, such as within riser shafts or when routing between floors inside a structure. It's designed to resist flame propagation and to limit smoke generation during a fire event. Plenum cable represents a specialized cable type designed specifically for installation in plenum spaces. These spaces include areas above suspended ceilings or inside air handling ducts. Plenum cable is manufactured to exhibit flame-retardant properties while also significantly minimizing smoke production. Considering the scenario described, the cable is being routed overhead using a ladder-type cable tray. Given that this setup does not constitute a plenum space, the use of plenum-rated cable is not required. Instead, OFNR cable is the recommended cable type for this particular application. There are several key considerations to keep in mind. Firstly, the cable tray system must be installed correctly and maintained regularly. This involves ensuring that the cable tray is securely affixed to the building's structural framework. It is also critical to properly bundle and secure the cables within the confines of the cable tray. Secondly, it is important that the cable tray is correctly fire-stopped at all penetration points. This entails sealing any gaps or openings around the cable tray wherever it passes through walls or floors. Lastly, the cable tray must be grounded properly. This involves creating a bond between the cable tray and the building's electrical grounding system. Adhering to these guidelines will help ensure that the cable installation is both safe and compliant with relevant codes and standards. To elaborate further on these points, let's delve into each aspect with more detail. Firstly, regarding the installation and maintenance of the cable tray, it's not simply about attaching the tray to the building's structure. The supports must be appropriately spaced and rated to handle the weight of the cables that will be installed. The hardware used, such as bolts, nuts, and hangers, needs to be corrosion resistant, especially in environments prone to humidity or chemical exposure. Periodic inspections should be conducted to identify any signs of corrosion, loose connections, or physical damage to the cable tray. Any such issues should be addressed promptly to prevent potential hazards or system failures. When bundling and securing the cables, avoid over-tightening the cable ties or straps, as this can damage the cable's insulation and affect their performance. Use appropriate cable management techniques, such as maintaining proper bend radii to prevent stress on the cables and ensure optimal signal transmission. Cables should be neatly organized and labeled for easy identification and maintenance. Secondly, addressing fire-stopping at penetrations is crucial for maintaining the fire resistance rating of walls and floors. The fire-stop material used must be appropriate for the type of penetration and the surrounding construction. Install the fire-stop material according to the manufacturer's instructions and ensure that it completely fills the gaps around the cable tray. Regular inspections should be conducted to verify that the fire-stop material is intact and has not been compromised by aging, damage, or modifications to the cable installation. Any breaches in the fire-stopping should be repaired immediately to prevent the spread of fire and smoke. Lastly, grounding the cable tray is essential for preventing electrical hazards and ensuring the safety of personnel and equipment. The grounding conductor must be properly sized and connected to the building's grounding electrode system. The connection should be clean and tight to provide a low impedance path for fault currents. Regular testing should be performed to verify the continuity and effectiveness of the grounding system. Any signs of corrosion or loose connection should be addressed promptly to maintain the integrity of the grounding system. In summary, the choice between OFNR and plenum cable depends on the specific environment in which the cable will be installed. OFNR cable is suitable for general-purpose applications, including vertical runs in riser shafts and horizontal runs in cable trays. However, plenum cable is required for installations in plenum spaces where it is necessary to minimize the risk of fire and smoke spread. By following the guidelines for cable tray installation, fire stopping, and grounding, a safe and code-compliant cabling installation can be ensured. It's important to consult with local building codes and regulations to ensure compliance with all applicable requirements. Additionally, consider consulting with a qualified electrical engineer or cabling contractor to ensure that the installation is performed correctly and meets all safety standards. Now let's consider some of the relevant standards and codes that govern cable installations. The National Electrical Code, or NEC, provides comprehensive requirements for electrical wiring and equipment in buildings. Article 770 of the NEC covers optical fiber cables and raceways. It specifies the types of cables that are permitted in different locations and the requirements for their installation. The NEC also addresses grounding and bonding requirements for cable trays and other metal enclosures. Another relevant standard is the Telecommunications Industry Association, or TIA, standard TIA 568. This standard specifies the requirements for telecommunications cabling systems, including the types of cables, connectors, and installation practices that should be used. TIA 568 also addresses performance requirements for cabling systems such as bandwidth, attenuation, and crosstalk. In addition to these standards, there may be local building codes and regulations that apply to cable installations. These codes may vary depending on the jurisdiction and the type of building. It's essential to consult with the local authorities to ensure compliance with all applicable requirements. When selecting cables, consider the environmental conditions in which the cables will be installed. Factors to consider include temperature, humidity, exposure to chemicals, and mechanical stress. Choose cables that are rated for the specific environmental conditions to ensure reliable performance and longevity. For example, if the cables will be exposed to extreme temperatures, select cables that are rated for those temperatures. If the cables will be exposed to moisture or chemicals, select cables that are designed to resist those substances. Proper cable management is essential for maintaining the integrity and performance of the cabling system. Use cable ties, straps, or other fasteners to bundle and secure the cables. Avoid over-tightening the fasteners, as this can damage the cable's insulation and affect their performance. Maintain proper bend radii to prevent stress on the cables and ensure optimal signal transmission. Label the cables clearly for easy identification and maintenance. Regular inspection should be conducted to verify that the cabling system is in good condition and meets all applicable requirements. Look for signs of damage, such as cuts, abrasions, or discoloration. Check the connections to ensure that they are tight and free of corrosion. Verify that the firestopping is intact and has not been compromised. Test the performance of the cabling system to ensure that it meets the required specifications. Any issues identified during the inspection should be addressed promptly to prevent potential problems. When making modifications or additions to the cabling system, follow the same guidelines as for the original installation. Use appropriate cables and connectors. Install the cables according to the manufacturer's instructions and the applicable codes and standards. Ensure that the modifications are properly fire-stopped and grounded. Test the performance of the modified cabling system to ensure that it meets the required specifications. Document all changes to the cabling system to maintain an accurate record of the installation. In addition to the technical aspects of cable installation, consider the safety aspects. Always wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and a hard hat. Use proper tools and equipment for the task. Follow safe work practices to prevent injuries. Be aware of potential hazards such as electrical shock, falls, and exposure to chemicals. If you are not qualified to perform the work safely, seek assistance from a qualified professional. Proper planning is essential for a successful cable installation. Before starting the work, assess the site and identify any potential challenges. Develop a detailed plan that outlines the scope of the work, the materials and equipment needed, and the schedule for completion. Coordinate with other trades to ensure that the work is performed efficiently and without conflicts. Communicate effectively with all stakeholders to keep them informed of the progress of the work. By following these guidelines, it's possible to ensure that cable installation is performed safely, efficiently, and in compliance with all applicable requirements. This will help ensure the reliable performance of the cabling system and the safety of personnel and equipment. To reiterate, OFNR cable is suitable for riser applications because it is designed to prevent fire from traveling up the cable in a vertical shaft. It has fire-retardant properties that cause it to self-extinguish, limiting the spread of fire. Plenum cable, on the other hand, is designed to be used in plenum spaces, which are areas used for air circulation, such as above drop ceilings or in air ducts. Plenum cable is made with materials that produce very little smoke when burned, reducing the risk of smoke inhalation in the event of a fire. When choosing between OFNR and plenum cable, it is important to consider the specific requirements of the installation. If the cable will be run in a plenum space, plenum cable is required. If the cable will be run in a riser application, OFNR cable is suitable. In other applications, the choice between OFNR and plenum cable may depend on the specific requirements of the project and any applicable building codes or regulations. It's important to consult with a qualified professional to determine the most appropriate type of cable for the application. The decision of which cable to use must also take into account local building codes. Many municipalities adhere to the NEC, but it is imperative to consult the local authority having jurisdiction or OJ for specific requirement. They might have amendments or additional rules that are more stringent than the NEC. Consider the long-term needs of the cabling infrastructure when selecting cables. Choosing higher quality cables with better performance characteristics can minimize the need for future upgrades or replacement. For example, selecting cables with higher bandwidth capabilities can support future network demands and technologies. In addition, consider the ease of installation and termination when selecting cables. Cables that are easier to work with can reduce installation time and labor costs. When installing cable trays, ensure that they are properly supported and securely attached to the building structure. The support should be spaced according to the manufacturer's recommendations and should be capable of supporting the weight of the cable tray and the cables it will carry. Use appropriate hardware, such as bolts, nuts, and washers to attach the cable tray to the supports. When routing cables through cable trays, avoid overcrowding the trays. Overcrowding can make it difficult to manage the cables and can also reduce airflow, which can lead to overheating. Leave sufficient space between cables to allow for proper ventilation. When terminating cables, follow the manufacturer's instructions carefully. Use appropriate tools and techniques to ensure that the terminations are secure and reliable. Label each cable termination clearly to facilitate troubleshooting and maintenance. Regularly inspect the cabling system to identify any potential problems. Look for signs of damage, such as cuts, abrasions, or discoloration. Check the connections to ensure that they are tight and free of corrosion. Verify that the firestopping is intact and has not been compromised. If any problems are identified, address them promptly to prevent further damage or system failures. Consider using cable management software to track and manage the cabling infrastructure. This software can help maintain an accurate record of the cables, terminations, and equipment in the system. It can also help plan for future expansions or modifications to the cabling infrastructure. In addition to OFNR and plenum cables, there are other types of cables that may be suitable for specific applications. For example, optical fiber cables are often used for high bandwidth applications such as data centers and telecommunications networks. Coaxial cables are often used for video and audio applications. Twisted pair cables are often used for Ethernet networks. The type of cable to use will depend on the specific requirements of the application. It is important to consider the performance characteristics, environmental conditions, and installation requirements when selecting cables. Also, ensure you know the differences between single-mode and multi-mode fiber if you are using optical fiber cables. Single-mode fiber is typically used for long distances, while multi-mode fiber is used for shorter distances. Each requires different equipment to function and have different costs associated with them. Always follow local and NEC guidelines when running electrical cabling near data cabling. Never run data cabling in the same conduit as electrical.